Hello, let's do the New York Times Medium Sudoku for March 31st, 2024. I got a request to do this one. Sometimes the medium can actually be harder than the hard. One thing I've noticed just before I even do this puzzle, I haven't looked at it yet, really, other than a glance, right? But one thing I've experienced with mediums is they tend to be more reliant on naked singles, which to a computer would seem easier, but sometimes naked singles can be hard to find. So let's see how we do on this one. It'll be instructive. And there's a link in the description if you want to try it yourself, and I'm going to get started right now. Okay, so I've got two 9s looking into here. This 9 looks up, so 9's in one of these two cells. Oops, 9. Oh, come on. We have two 4s looking in here. This 4 looks up, so 4's in one of these two cells. We do have two 5s looking up. This 5 looks in, so 5's in one of these two. Okay, what else is going on here? This 6 is looking up into here, and this 6 looks in, so we do have a hidden 6 there. These two 6s now look into this box, putting a 6 up here. These two 4s look down. That places the 4 here. That puts a 4 in one of these two cells, and that does what's called pointing. So I'm going to make sure I go over these techniques because this is the medium. So if you're watching this, if this is the first video, hi. I post the hard every day. And I try to explain every technique as I go to be instructive rather than, I'm not trying to be impressive, just instructive. So what is going on with these corner marks in the first place? Well, I'm using corner marks to say where a digit can go in a box. So in box 7 here, this is if we count left to right, 1, 2, 3, 4, 5, 6, 7, right? So in box 7 here, we have limited the 4 to just these two cells. And it just so happens that these two cells are both in row 7. This is row 7. So they're both in the same row. So no matter where the 4 ends up, the 4 could be here or the 4 could be here. But those are our only two options for where the 4 goes in this box. Both of those are in row 7. And each row, column, and box has only one of each digit, has exactly one of each digit. So the 4 is over here. So that means it can't be over here as well. Now it's obvious here that this 4 takes out of here, but it's not so obvious that this cell in particular is not a 4. And the reason it's not a 4 is if we try to put a 4 in there, there is now nowhere to put 4 in this box. Or alternatively, because the 4 is over here, it's not here. So hopefully that makes sense. It's called pointing because our corner marks kind of line up, and you can kind of think about if you draw a line between them, they point in that direction, or they point along that direction. So they point at the rest of the row and say no more 4s. So these are not 4. This 4 looks in, this 4 looks down. And so 4 ends up in one of these two. And the important thing to remember is that this one's not a 4. Just looking at 4s, we do also have these two 4s looking in, this 4 looking down, so that does put a 4 in one of these two as well. Is there anything else I can do up here before I move on? I do have this 8 looking in and this 8 looking in. So that does put an 8 in one of these two cells. That's not going to point though, right? Even though it's down to 2 in the box, they don't share any rows or columns. This is in row 1 and column 6. This is in row 2 and column 4. I do have 4. I have a 4 in the box already. The 2 looks in. And this 2 looks in, so that puts a 2 in one of these two cells. Now, something I'm noticing about this box is I have the 2 and 8 corner marked in it, but these two cells don't have that 2 or 8, right? And so in addition to not being 4, 6, 7, 9, they're also not 2, 8. So that is already 6 digits that they're not. And there are 9 digits in total. So it's worth thinking about what these can actually be, because whenever a cell is down to 3 or fewer possible digits, I like to use center marks to mark what the possible remaining digits are. So just for the box, we know that they can be 1, they can't be 2, they could be 3, they can't be 4, they could be 5, they can't be 6, 7, 8, or 9. And this 5 here is actually telling us that this can't be 5 either. So this is down to 1, 3 only, and this is down to 1, 3, 5 only. And that's exactly what I was talking about, 3 or fewer open digits. Okay, so we can't do anything with that immediately, but it might come in handy later. I'm also noticing this cell is avoiding a bunch of corner marks. So let's think about what it can be. It can be 1, can't be 2. So it could be 1, 3, can't be 4, 5, 6. It could be 7, can't be 8 or 9. So we're down to 1, 3, 7. That's worth keeping because it is 3 or less. This box in general is down to 4 open cells. When there's down to 4 open cells, that means there are only up to 4 per cell. So if any of these cells see a digit that isn't already in the box, like this cell sees this 3, this cell sees this 2, both of these see a 7. So actually, let's mark that first. This 7 looks in, putting a 7 in one of these two. That is going to point down, but we don't have any other Okay, we do have one other 7 that's useful. This 7 here, these 7s point down. And I will finish that earlier thought. But that does put a 7 here. It's always important to follow up on what you've gotten as soon as possible so you don't forget. But anyway, so in this box, I think it's going to be fruitful to mark what it needs. It needs a 1, 2, 3, and 7. So if I mark that out, you can see this can't be 3 or 7. So it's down to just 1, 2. This can't be a 7, as we saw. And this can't be a 2, as we saw. Now this one is down to 4 digits. I am tempted to leave it because it matches these pretty well. 1, 2, 3, 7 only adds the 2 as another unique digit here. I'm going to think about the entire row. The entire row needs 1, 2, 3, 4, 5, and 7. If this cell couldn't have been a 5, that would, or sorry, 1, 2, 3, 4, 5, 7. So that 1, 2, 3, 4, 5, 7. So this can't be the 4, but it could be the 2. If this couldn't be the 2 or the 4, then that would have made a hidden 2, 4 over here. In fact, it would have placed the 2 here, but we are not that lucky, and I don't think we're going to find anything like that, so I'm not going to keep that marked. I like markings, but only if they're useful and don't just add clutter for no reason. So that's what we're trying to do here. Is there anything else going on in this top band before I continue? 6 and 4. So we already have the 4s marked. We already have the 6s marked. What about 9s? Yeah, we have the 9s marked. Okay. I think we're good. I think let's move on. So now I'm gonna focus on this band. I know it didn't seem quite like it, but I was technically focused on this band that whole time. But I also want to look at interactions as I go. That's why I am looking at the whole board. But my focus was to get this top band marked up. Now we're gonna get this band marked up. We just call a row of 3 boxes a band. We call a stack of 3 boxes a stack. I don't know. A column of 3 boxes a stack. That's generally the nomenclature. So we already got these 4s. 4s are over here. Is there anything else of note to do here? I'm noticing 2, 5, and 9 are pretty unique here. But there's plenty of places to put them. I'm honestly not seeing much to do here, so let's just move on. Okay, so we have, it's interesting that it shows up in Medium. I didn't know it showed up in Medium, but we do have our classic New York Times trick. It's called a New York Times trick just because New York Times puzzles have this a lot. Not every time, but a lot. It's also a really nice way of just finding what's called a hidden triple. So why have I highlighted this 3, 5, and 7 in green? Well, the question we want, the first thing to notice is that these 3 digits that are given in this box are all not in row 8. This row just doesn't, they're not touching this row. They're only in row 7 and 9. So we know that this row is going to need a 3, 5, and 7. And we also know it's not going to get them from these black cells here because they share a box with 3, 5, and 7. We also know that these 3 cells are given as not 3, 5, 7. Well, this 4 we filled earlier, but the 6 and 9 were given as not 3, 5, 7. And then we found out this is a 4, which means it's not 3, 5, or 7. So the question we want to ask is, where do 3, 5, and 7 go in the row? I am noticing we can do something a bit more, but let's just go over this kind of without looking at context first, other than these. All you need is this row and these 3 digits, right? So the answer is there are only 3 cells left that could accommodate 3, 5, and 7 in this row. They're not in any of the black cells, so they must be in the 3 purple cells. So the result is that whatever we think could go in purple, the answer is only if it's 3, 5, 7. So let me try to find an example. We might think that this could be an 8. That's one example, right? If I fill 8 there, it doesn't turn red. There's no 8 in the column. There's no 8 in the row. There's no 8 in the box. So why wouldn't 8 be a candidate? Well, the answer is I need to put 3, 5, and 7 in this row. And now there are only 2 places that it could go. This would be black, right? And I can't fit 3, 5, and 7 into 2 cells. And so one of them would get crowded out and the row would not have one of 3, 5, or 7 in it, at least. And so that's no good. We've broken the puzzle because we need 3, 5, and 7 in the row, one of each. So the conclusion is that these are only 3, 5, and 7. So if I fill out 3, 5, 7, something else you'll notice is that these 2 3s here that I mentioned earlier, tell us that these 2 digits are not 3. So really what we found is we found that 3 in this row is hidden. It's a hidden single because there is only one cell, this cell, that can actually have 3 in the row, so it must. And then that leaves us with a hidden 5-7 pair in the remaining 2 cells. But it's okay to have seen that through the triple. However you see it, that was the right way to see it because it got you the deduction. If you see a finned jellyfish for whatever reason in a puzzle that didn't need a finned jellyfish, it was still fun to find and it still got you progress. So I love it. Okay, so in this row, we are down to 1, 2, and 8. So we know we need a 2 in the row, and these 2 2s are telling us they're not here. So that leaves just this cell for 2. So that's a hidden 2 in the row. And then we have a pair remaining because we know 5 and 7 are over here. So what is our remaining pair? Well, we need a 1. We have the 2, 3, 4. We have the 5, 6, 7, and 9. So we need 1 and 8. So that 1, 8 pair is going to tell us that for the rest of the box, we can't be 1 and 8 because they're here. These cells can only be 1 or 8. That's it. We don't know what order they go in, but one of them will be 1 and one of them will be 8. So how are these ever going to be 1 or 8? Like you might say, hey, why can't this cell be a 1? Seems like it could be a 1. Well, look a little closer. Now, where are we going to put a 1 in this row? Where are we going to, right? Or if we try to make this an 8, where are we going to put an 8 in this row? This pair of digits can't both be 1, can't both be 8. And so they're going to be 1 of each, and that's going to mean that the rest of the box can't be 1 or 8. So we can fill the remaining 3 digits, right? We know that we need a 3. Oh, no, sorry, we don't need 3. 3 is already in the box. We do need a 4, which we know is already up here from our corner marks. We also need a 6, and we need a 9. That's it. This one's not 9 because of the 9 in the column. Okay. And again, I knew that that would be worth filling because it was 3 digits, and I always fill 3 or fewer if I know that a cell's down to that. Okay, so let's take a step back. We just got a bunch of information about this band. Let's make sure we got everything that we could have out of it, and then let's look at the follow-on consequences that we may not have noticed yet. So we have all our 3s. We got these 7s marked. 2s. So there's 2 2s looking in here. And so 2 ends up in one of these 2 cells. And I did scan up here because I noticed that we had some 2s marked up here, but unfortunately they don't point or anything. They don't really tell us where the 2 goes. I'm also looking at this column and this column to see if 2 happens to be quite limited in that those columns, but it doesn't seem to be true. So those are things I'm scanning for every time I pencil something. And triggering those kinds of scans when you pencil it means that you're not having to go back and find it later. You're just finding it right away. And that can really speed up your solves. I know this solve seems slow, but it's because I'm sitting here and trying to explain everything as best as I can. Again, not trying to impress. I'm trying to be instructive. So this 6 is looking down into this box, which I just noticed. So that means 6 is in one of these 2 cells here. And so that's going to point. We went over pointing earlier, but basically the 6 is going to always end up in column 4 in this box. Always in this column, which means these can't be 6. This 6 also looks in, this 6 looks down. So that means 6 is in one of these 2 cells in this box. The important thing to remember, most important thing to remember is these 2 cells can't be 6 because there's not something immediately telling us that other than our markings that we just put in. Okay. I don't think I'm going to get anything else out of this band. So now what I do is I'm going to scan the stacks. And I've already done a lot of stack scanning, but we're just making sure I didn't miss anything obvious because I haven't given my full attention to each stack yet. And I want to do that before going into sort of the next phase of scanning. So this stack, I'm not really seeing anything else to do. We already have it basically marked up. This stack here, we have 4s. Okay, so this 9 is looking down. And this 9 looks in, right? These aren't 9. So 9 ends up in one of these 2 cells. Again, that's going to point up. This 9 is going to look in. This 9 is going to look down. Now we have a 9 in one of these 2 cells. So now what have we done here? Well, we have corner marked in this box 6s and 9s, nice, into the same 2 cells. So what we have found, because we have 2 values corner marked in 2 cells and no other cells, like if I had a 6 or a 9 cornered over here or over here, like it wouldn't work. But because it's the same exact 2 cells and only 2 cells that have a 6 corner mark and a 9 corner mark, that immediately tells me that I have a hidden 6-9 pair. And the reason for that is 6 needs to go somewhere in this box. It's going to go in one of these green cells. 9 needs to go somewhere in this box. It's also going to go in one of these screen cells. So how could anything else go in those cells? We need the 6 and the 9 to appear in the box somewhere. And the only place they can appear is these two cells. And so we can convert the corner marks to center marks and say that this is 6, 9 only. And that leaves just 1, 3, 5 here, but this 3 tells us it's actually only 1, 5. And so now if I look at this column, or if you prefer, if you look at this 1, 3, 5 triple, we know this one's not 3, which means one of the other two ends up 3. And so we can corner mark that in this box. And that tells us that only one of these two is a 3. We also would have seen that from scanning, but it may not, it could have claimed if we didn't already have these 3s. So interesting to mark regardless. Okay, is there anything else to find in this stack? We got the 6 and the 9 here. We already know about the 6s and 9s kind of in the other boxes, so nothing really to follow up there. There's nothing really in the rows that tells us anything interesting because of the 6, 9. What we may want to think about is what was removed from these cells. Well, it wasn't the 3, it was just the 1 and the 5. So 1 and 5 can no longer be in these two cells. And is that interesting is the question we want to ask. Well, we want to ask, what do we know about 1s and 5s in the box? And I think the answer is just that we know this 5 looks in, and now this can't be 5. So 5 is down to these 3 cells, which is not really worth marking, but it is interesting to maybe keep in the back of our heads if we ever return here. Okay, I don't know that there's anything else in this stack worth looking at. I can see that this cell is not 2 or 5. And I can also see that there are 5 digits remaining in the box to be placed. So if we do 5 minus 2, that's already down to 3. So this is worth marking. It looks like it can be 1, 3, or 8. Or not 3. Oh, it also can't be a 3. Oh, yeah. So let's just double check. It can be 1. It can't be 2, 3, 4, 5, 6, 7, or 9. So it is down to 1 or 8. Is this one also can't be 3 or 8 at least. So this can be a 1 or a 2. It can't be 3, 4. I think it could be, oh no, it can't. Yeah, it could be 5. It could be 5. Can't be 6, 7, can't be 8 or 9. Okay. Down to 1, 2, 5. Okay. I think that stack, I think we've gotten what we can out of it. We may return. This stack here, we do have 2 9s looking down here, and this 9 looks in. So 9's in one of these 2 cells. This column needs a 3. Where's it going to get a 3 from? Well, this 3 says not here. This 3 says not here. None of these are 3. So we have to place the 3, and it could only go there. We're down to 3 digits in this column. And we know that this one's not 2 or 7, because we need a 2 and a 7 in this column. And these corner marks are telling us that in this box, 2s are here and 7s are here. So this is not 2 or 7. So this is a naked single. This is a 1. The only digit it can be. And then this is a 2-7 pair. And I don't think it's resolved yet. Okay, what else can we see here? So we just got a bunch of 3s. So let's think about 3s for a bit. Okay, we have these 2 3s looking over. That places a 3 here. That means this is no longer a 3. These 2 3s look up. So one of these 3 is a 3. It's getting a little crowded in here, but I am gonna mark it. But I debated not marking that. I just noticed this box is down to 4, so let's think about it. We just placed that 3, so that triggers this sort of scan here. So we need 1, 6, 7, 8. We know this 7 looks in. So 7's in one of these 2. That means these are definitely 1, 6, 8. I'm not sure 1, 6, 7, 8 is useful in these cells. I think it's all 4. I'm not seeing anything looking at that. So we'll just leave those as cornered 7s. Okay, I'm not seeing anything else immediate to do with that. So let's return to this stack that we were looking at. Is this still just down to 1, 2, 3, 7? It looks like it hasn't been improved. Okay. Well, down here, we know these aren't 2 or 7, so these are probably worth marking, because that minus the 2 and 7, they're down to 3 digits max. So they're not 1, 2, 3. They could be 4, 5. They're not 6, 7. They could be 8. So they are down to 4, 5, 8. Unfortunately, all 3 of them. In fact, actually, look at this. This 8 tells us that 8's not here. And we know this isn't an 8 because of our 1, 8 pair. So where is 8 in this box? I guess you could also say this 8 looks in, this 1, 8 pair looks in. So 8 in this box ends up over here in one of these 2 cells. Look, we found another hidden pair. We have the 4s and the 8s corner marked in 2 different cells. So this cannot be 5. It has to be a 4-8 pair. We've eliminated 5 from here. And that leaves just 2, 5, 7 for this cell, but it's not 5 either. So this 5 looks in, and this 4-8 pair told us these aren't 5. So 5 can only go here in the box. And that when I placed that 5, it removed a 7 corner mark because it didn't end up 7. So where's 7 in the box? Well, our corner mark immediately tells us it's only here. And then now our 2 corner mark immediately tells us 2 goes there. So you can sort of do that very quickly. This 2 is looking up into here, placing 2 here. This corner mark 2 is now red, which means 2 gets placed there. We also have this 7 here because we placed the 5. So let's clean this up a little bit. That's not 2, these aren't 2. This is down to 1, 3, 7 only, which is a 1, 3, 7 naked triple. So if 1, 3, 7s are up here, this is a naked triple here. We've whittled these cells down to just 1, 3, and 7. And it's 3 cells. So, and they all have to be different. So if all 3 cells have to be different from each other, and 1, 3, and 7 are the only choices for what to fill in them, they're going to end up as 1, 3, 7 in some order. We don't know what order, but in some order they'll be 1, 3, 7, which means these cannot be from 1, 3, 7. So these are from, let's think about it at least. These are from 4, 5, 8, and 9. So this one's not a 5, so this is down to 4, 8, 9. This one's not a 4, so this is down to 5, 8, 9. Not a 9 either, actually. It's down to 5, 8. I'll put another cough drop here before I start coughing. I am getting over a pretty nasty cold. Okay. 4, 5, 8, 9. This one's not 4 either. So this is down to 5, 8, 9. This row is down to 4 digits as well. We need a 1, 5, 7, and 8. I know this is down to 1, 1, 7, 8 because it can't be 5. I think this can be any of 1, 5, 7, 8 though. Okay, what were we doing? We got this 2 and 6. So let's think about this column as well. We need 1, 4, 7, 8. 1, 4, 7, 8. This one's not 4, so this is 1, 7, 8. This can be any of them. Interesting. We know that the 1 and the 4, or sorry, the 1 and the 7 are over here. So let's corner mark that. Okay, so now I believe we have finished our band and stack initial scan. So the next thing we want to look for are any rows, columns, boxes we haven't already looked at that are down to 4 or fewer open cells. So for example, this column we haven't looked at yet. So let's take a look. We need 1, 5, 8, 9. So where's the 5 in this column? This 5 says not here. This 5 says not here. This 5 says not here. So there's only one open cell that can be 5. So this is a 5 for the column. Now this is the 9 for the box based on our corner marks. So this cannot be 9. That places a 9 in this box. Only one place left for it. We also have a 4, 6 naked pair here, which means this is not a 6. That places the 6. And this is a 1. This 9 looks up. It took one of our 9 corner marks. We scan real quick. There's only one 9 corner mark left, so we place it as a 9. Very nice. This is down to 1 or 8. I can just reference that 1, 8 there. See, we're down to 1, 8. I don't think it's resolved though, but we'll fill it. Okay, we just got this 9. We just got this 4, 6 pair. We've had this 1, 8 pair. I'm just making sure I followed up on everything. Let's look at this column. It is down to 1, 6, 7, 8. So where is 6 in this column? This 6 says not here. This 6 says not here. And this 6 says not here. So this is the only place for 6 in the column. That used up a 7 corner mark, so it places 7 in the box. And it also gives us this 1, 8 pair here, which tells us that 1, 8's not in the rest of the column. But this 6 also gives us this 9 and 6. This 7 eliminates one of the places for 7 in this box, but there's still 2 places left. This 9 removed 9 from here, which means 9 is only here now in the box. So we can place that. And that was actually our final 9 of the grid. Excuse me. Whoa. We have a 1, 8 pair in this row. So the question we really can ask is, where's the 5 in the row? And the answer is only here. So this is our 5. That gives us the 1 here. Gives us our 8. That finishes the 4. Eliminates this 1, but there is still 2 places for 1 in this column. But we do get a 1 here as well, because we got this 8. So this is a 1 and an 8. This is our 1. This is not a 1. So this is down to 5, 7, 8. But it's not a 5 or an 8, so it's only 7. That's 8 and 5. Let's just clean up this box. This box, we get the 3, the 1, and the 5, and the 8. This box is also done. Oh, it's not quite done. We do get this box finished, though. 8 and 4. 5 is eliminated from here, so there's only 1 place for 5 in the box. If we eliminate this 3 from this 3 over here, there's only 1 place for 3 in the box, and now only 1 place for 4 in the box. That looks down, giving us the 6 and the 4. This 3 looks right, giving us the 1 and the 3. This 1 looks back left, giving us the 7. This 6 looked up, placing 6 in this box, only here. We are down to 1 and 8, and this 1 tells us that this is 8, this is 1, which then resolves this box as well. And now this box needs a 2 and a 7, and we are done. So because this was the medium, I definitely took my time explaining everything. Yeah, it felt like it could have been marked as a hard difficulty for sure. I think this may have been one of the harder mediums. Maybe I missed some naked singles. My strategy finds the hidden stuff much more easily than it finds the naked stuff. I'm pretty much only finding naked singles during those first initial passes, if it happens to be in a row or column or box with 4 or fewer open cells. So we did find quite a few naked singles as we went, but we weren't like hunting for them immediately. Maybe one thing I'll do is let's just find out if there were any immediate naked singles in this puzzle. So just give me a moment for that. Okay, so let's go over what this solve would look like if you were using automatic candidates, basically. So what I've done is I've just penciled every single cell with its possibilities, just naively. Some people like to solve this way. I don't recommend it because I find it a little boring. And if it's boring, like if it's just a lot of, if the solve is boring, if you're not going on an adventure in your solve, you're just going to get bored of Sudoku. But if you would like to see what this looks like, you can see with automatic candidates that it immediately sticks out that this is naked single 1. I did not find this naked single 1 for quite a long time because that is not what my scanning strategy is looking for. But you can see that this cell sees 2, 3, 4, 5, 6, 7, 8, and 9. So you just need its column and its row to see that it's a naked 1. Right at the start, maybe if I had looked and seen, okay, this column is starting out with only 1, 2, 3, 7 available, I would have seen this 1, 2, 3, 7 and gotten the naked 1. But once you get that naked 1, let's just simulate auto candidate here. You get all of those 1s eliminated. And now the next thing you might notice is that because we eliminated that 1, we end up with a 2, 7 pair here. Or if you prefer, the 3 in this column is now limited to just here. So you get the 3 as well. So let's see. Is there any other low-hanging fruit before I show you some other things? And you can see that when you're this marked up, it's a lot harder to see a lot of the things that you kind of take for granted seeing in the initial scan. And it feels like you want to kind of just look at the empty cells rather than looking at what the givens are trying to tell you. But I'm scanning this and I'm seeing this 1, 3, 5 triple that we found midway into the solve. It kind of stands out to me. Once you're good at scanning this sort of thing, you can pick out these triples pretty easily. But this is a 1, 3, 5 triple, right? So these can't be 1, 3, or 5. So we can eliminate the 1, we can eliminate the 3 here and the 5 here. And then now we have this 6, 9. Oh yeah, sorry. Did I eliminate the wrong things? Okay, 1, 3, and 5 are eliminated, and that does make this a naked 4, right? So we can just fill the 4 there. These aren't 4 anymore. Oops, aren't 4. These aren't 4 anymore. That's not 4 anymore. And then now we see a 1, 2, 8 triple here that formed because we eliminated the 4. So we can eliminate 1, 2, and 8 from these cells, leaving a 5, 7 pair, placing the 3. And also 1, 2, and 8 can be eliminated from the box. So these aren't 1, that's not 2, that's not 8, leaving a 4, 6, 9. You may notice the pointing at this point. Let's see if there's anything a little bit more obvious to do. So yeah, basically if we're trying to flow this puzzle, maybe we would notice that 4 ends up limited to these two. And I'm going to avoid using quarter marks because this is kind of simulating you're using the New York Times app with like auto candidate on. Because this 128 left us with a 4, 6, 9, we see that the 4 is in one of these two. So this can't be a 4, leaving us with a 2, 7 pair here. So none of these can be 2 or 7. Specifically, this one's not 7, so we get the 5 and the 7 here. And now auto candidate removes these 5s, giving us this 4, 8 pair. This is 5, 6, 9 already, so that's not helpful. We also have a 2, 7 pair here, meaning these aren't 7, but we also got the 7 in the box. So this 5 looks up, eliminating 5 from these. And this 7 looks up, eliminating 7 from there. I am now seeing a 1, 2, 3, 7 quad in this column. Don't know why that was the next thing I spotted, but there it is. Notice 1, 2, 3, and 7 are limited to these 4 cells. I don't know if there's something simpler, but if you notice something, use it. So these are not 1, 2, 3, or 7, leaving a 5, 8, 9 triple. So these are not 8. 5, 8, 9, no, it is not a triple. Sorry. We're left with 4, 5, 7, 8, 9. But in that 1, 2, 3. Yeah, I should have eliminated 7. It's a 4, 8, 9 triple. Sorry. So these are not 8 and these are not 4. I messed up. Hold on. Let's go back to when I was messing with this. We have a 1, 2, 3, 7 here. So these are not 1, 2, 3, or 7. They're not 1, they're not 2, they're not 3, they're not 7. So we're left with a 4. Yeah, this is 4, 5, 8, 9, right? This is only 4 or 8, so the 5 and the 9 end up in here. So these aren't 5, 9, but we already knew that. So okay, we can't eliminate anything. Sorry, this is not my standard way of solving, so I'm going to make mistakes. So what else is happening here? So my theory about it being a bunch of naked singles is wrong. I don't do the medium very often, so I don't have the instinct for what we're looking for. But you can see at this point, it's actually kind of hard to scan it. Like, what are we actually looking for? The deductions we've already made, we've done the eliminations for them, and they haven't really led us anywhere. And so now we have to kind of step back and start over and just rescan for like something that we might have missed. This 6, 9 pair, for example, that we got, I didn't eliminate the 6s and 9s right away. Often what'll happen is you get overwhelmed with deductions from finding something and you forget to go back and apply it everywhere. That's going to be pretty common. Maybe some people are better at that than me. But for me, again, my scanning strategy keeps my momentum going and keeps me applying where I need to most efficiently apply things. But anyway, we got that 6, 9 pair. That eliminated 9 from... What did we just eliminate? We eliminated 6 from here and 9 from here. So we want to think about what that did. So we already know that 6 is in one of these and 9's in one of these. We also know 5's in one of these. Okay, so I'm not sure we can do much with that. What else can we see? So again, I'm trying to do this marking centric scanning. 1, 2, 4, 6, 8. Nope, not helpful. And you can see it's very easy to get just stuck because you don't know. The information that's being given to you is overwhelming and wasn't plunked by you. So like you don't really remember what's going on or what might be interesting to look at. So you just kind of have to stare at it and scan until you see something. And this puzzle depended on quite a few hidden singles, if I recall. And we haven't found a single hidden single, right? We found naked singles, right? We found pairs and triples. It can be really hard to find a hidden single when it's all marked up like this, especially in rows and columns. But let's do our best to scan here. Yeah, this is tough. There's not much to see here. This is not the right way to approach puzzles. Okay, I'm seeing it in this row. Where's 3 in this row, right? If we had done this scanning, we immediately see this hidden 3 in this box. But with it all marked up like this, how do we know that we're looking for that? Without going through and looking what the givens are trying to tell us, how are we knowing that 3 is limited in this row? You have to just kind of stare and go, oh, okay, I think I see 3 is limited in this row. Some people have better pattern matching than others. For me, this is hard to see. So that's why it's called a hidden technique, by the way. Hiddens feel more obvious when you're using scanning like this. It's like, why is it called hidden? It's the most obvious deduction. But if you're just staring at the grid like this and you're like, oh, obviously row 4 has only one place for 3. You're better at scanning that than I am. So that's a 3. These aren't 3 anymore. Now, what does that get us? Not a whole lot. So we got to keep looking for stuff. We're trying to follow up on this 3, but I'm not really seeing much to do with it. So we just got to keep looking, right? And this is getting kind of boring for me. I don't know if I want to finish the puzzle this way. I'm seeing this 1-8 pair here. I somehow missed that for a while. It means that in the rest of the row and box, row's not important, but in this box, the 2 can only go there. So that's our hidden 2. I don't know that that helped. Yeah, not much to do with that 2 there. It makes deductions hard, easy deductions hard to find, and then there's almost no follow-up on them sometimes. And so it just like feels bad. It's like, oh, now I have to just look for more things again. Anyway, what are we looking for here? So this is where I'd really recommend just starting to look at the givens and not at all these markings. We haven't found the important stuff in our initial scan. We haven't marked those corner marks in our initial scan. And it's really hard to remember what's important. 6 in this box. Here we go. 6 in this box is only right here. So let's fill that. These aren't 6. 1, 4, 3. I know I don't even remember like the puzzle well enough to like cheat and be like, oh, that's what we need to do next. We know this is only 1 or 2, and so this is 4 and 8. So the 7 in this column, yeah, here we go. The 7 in this column is only in these 3 cells. That means this can't be a 7. If you look at this column and what we've marked up, 7's only in these 3. So if we try to put a 7 here, there won't be a 7 left for this column. All right, if this was a 7, there'd be no 7 in this column left, and that would be bad. So this is a 2, not a 7, and that resolves all of these. These aren't 2. These aren't 2. I'm not going to even have a time for this, but that's okay, because I didn't restart the timer. I guess it's in the video. Let's see. What does that get us? We got these 2 2s, so we might want to think about 2s a bit more. 2s are in one of these 2. Okay, again, we got digits, and it doesn't feel very satisfying because it didn't do much for us. 1, 3, 7, right? So 2 in this box now is important. So that the 2 goes there. This is not a 2. 2 in this box is now here. So basically what we have to do is we have to keep in our heads, okay, we just got some 2s, so let's look at what happened with 2s in these various boxes. 2 ends up here. 2s are done. We have 1, 5, so 7 is in one of these 2. Okay, that doesn't matter. We have a 1, 8 pair in this column now. So this can't be 1 or 8. This is 9. That's 5. That's 6. That's 1. And now we might be getting into the territory where it's just very fast to finish with auto markings. Now that we found enough, but we'll see. This is not a 9, so we get another 1, 8 pair here. So this ends up 7 and 6. Let's just follow around our red for a bit. 1, 8 pair means that has to be a 7. These are not 7s for multiple reasons. These aren't 7s. 7 in this box now goes there. We're thinking about 7s, so we're just following those around. I feel like we're missing a 7 somewhere. Yeah, up here. Okay. All right, 7s are done. I'm seeing 1, 3, 6, 8. The 6 is over here. Doesn't really do much. 1, 8 pair means these are not 1s or 8s, so we can clean that up. Okay. So now we have to find something else. We're almost done though. Again, we have a 1, 8 pair here, so these can't be 8. So we get the 5, the 4, and the 9. We get our 1 and our 8 and our 5. 1 and 8. We get our 8, 3, 1, and 5. We get our 1, 9, 4, 3, 6, 8, 5. 3 and 1, 8 and 1, 4 and 8, 8, 1, 6, 4, and we're done. So we still needed the same techniques that I was using in the original solve. Maybe not all of them. Maybe not every single thing I found, but we still needed quite a bit. And I was wrong about this puzzle needing a bunch of naked singles. So Actually, this puzzle really benefited from techniques that I used in the original solve. Benefited from like these claiming 7s, right? That was a really important deduction. The hidden 3 here, for example, that wasn't that. I don't know if that was important or not, but that was kind of hard to spot with everything penciled up if we're not paying attention to where we have digits rather than where we don't have digits. So yeah. Maybe that was instructive. If that's the way you want to solve, if you're using the New York Times solver, for example, and you've got auto solve on, those are the kind of things you need to look for. You got to spot those pairs and triples, maybe even quadruples. You got to spot obviously the naked singles pop out, so those are just given to you for free. But there's still things you got to spot. You got to spot pointing and claiming. You've got to spot the hidden singles, which can sometimes be difficult when they're in a row or column. But yeah. Hopefully that was instructive. Hope you enjoyed that. I know this is a long video, but when I get a request to do the medium, I feel like that's coming from someone who isn't as experienced and might want to learn more about how to approach solving Sudoku. So those are 2 different approaches. You can tell which one I prefer. I had a lot more fun with the first approach, but yeah, any feedback's appreciated. And if you enjoyed this, then why not leave a like, subscribe, and a kind comment below.